You remembered! You came back for more information on Alzheimer's disease. This is the YouTube channel that is all about education. And the education pertains to menopause. Well, that means it pertains to the rest of your life. And it means it pertains to the diseases you want to avoid the rest of your life. I'm Menopause Taylor, your teacher, and we're working our way through a great big unit on Alzheimer's. This is video number 242, and it's the 7th video in the Alzheimer's unit. And it's absolutely critical for you to watch all my videos in order. Otherwise, you're just shooting yourself in the foot. And in the case of Alzheimer's, you're shooting yourself in the head. So far, I've taught you about all of the following things. In video number 236, you learned about the basic building block of your brain called a neuron. In video 237, you learned about the outer coating that insulates your neurons. In video 238, you learned about all the things that contribute to how your brain builds up or breaks down. In video 239, you learned some very basic brain anatomy pertinent to brain aging and Alzheimer's disease. And in video 240, you learned about the different kinds of memory. And in video 241, you learned about the different kinds of dementia, one of which is Alzheimer's disease. So today, we're finally ready to talk specifically about Alzheimer's disease. And you'll need all the videos that preceded this one to benefit fully from this one. Don't be mad. You will learn much later that one of the ways you can decrease your risk of Alzheimer's is to learn things sequentially rather than jumping around randomly in the way you accumulate information. So, in my book, you'll find Alzheimer's in chapter 33. The whole chapter is Alzheimer's. But you should still watch this video because I will give you much more detail on the pathology of Alzheimer's disease in this video than I could possibly give you in my book. So let's start by defining Alzheimer's disease. From there, I'll teach you what's really happening in your brain when and if you develop Alzheimer's. Alzheimer's disease is an irreversible, progressive type of dementia that slowly destroys your memory, thinking skills, and eventually your ability to carry out the simplest tasks. So right away you see that Alzheimer's is a type of dementia, but you already knew that because I covered it in the last video entitled Different Kinds of Dementia. Well, it turns out that Alzheimer's is the most common type of dementia. It accounts for 60 to 80% of dementia. Our focus today will be on what causes Alzheimer's in terms of your brain anatomy. In other words, we'll talk about Alzheimer's pathology. We'll base it on what I've taught you in the previous Alzheimer's videos. And in next week's video, I'll address the symptoms and diagnosis of Alzheimer's. So let's go back to what you learned in the first 2 Alzheimer's videos. Remember this? This depicts the basic building block of your brain, the neuron. And the neurons constitute your gray matter. That's why they're gray. And they are surrounded by the other basic building block of your brain, which is the myelin. The myelin constitutes your white matter. So far, I've taught you that everything you learn and remember depends on these 2 basic brain structures. The neurons communicate with one another, and the myelin insulates them so that they can communicate rapidly and efficiently. Well, all that changes if you start developing Alzheimer's. So, let's create an Alzheimer's board. Alzheimer's involves 2 pathological features that rob your brain of its ability to function properly. I call them pathological robbers. And they both have complicated medical names, but you know me, I'll simplify them for you. So let's address these two pathological brain robbers in turn. The first pathological brain robber is something called an amyloid plaque. Amyloid is a kind of protein. There are different types of amyloid protein, and the one that concerns us with regard to Alzheimer's is beta amyloid. Beta amyloid is a normal brain protein, but sometimes it malfunctions. When it does, it can lead to Alzheimer's. You know, proteins are really quite phenomenal. They can do all sorts of things. Throughout your entire body, you have proteins that combine things, proteins that cleave things in two, proteins that transport things, etc. Proteins can do just about anything you can imagine. But each protein is programmed to do just one thing. Each protein has one very specific job description. So beta amyloid happens to really be a small piece of a larger protein called amyloid precursor protein, or APP. You know, I'm very slow when it comes to technology. And the first time I heard someone say AP, I thought they were talking about amyloid precursor protein. It took me the longest time to realize that their use of the word or semi-word or abbreviated word or whatever it is, AP, didn't mean amyloid precursor protein. But the acronym APP will make it easy for you to remember this, even though you don't really have to remember it. Amyloid precursor protein functions in helping your neurons connect with one another. So here's a second neuron. In other words, it contributes to your ability to learn new things. So it has a role in making sure the most basic building blocks of your brain work properly. Amyloid precursor protein lives inside your neurons, and under normal circumstances, amyloid precursor protein, or APP, is cut into shorter fragments. And some of those fragments are released to the outside of the neuron. Well, one of those shorter fragments that is released outside the neuron is beta amyloid. And under normal circumstances, beta amyloid helps your neurons change and adapt to new information. So under normal circumstances, beta amyloid is beneficial. So let's liken beta amyloid to tape. It enhances the ability of your neurons to connect with one another. So it enhances this connection and makes it better. Okay? The detrimental thing about beta amyloid is that it's stickier than other fragments of amyloid precursor protein. And sometimes it's just too sticky. So let's represent beta amyloid that is too sticky with Velcro. And when it's too sticky, instead of beneficially enhancing communication between neurons, it sticks to other fragments of beta amyloid and accumulates outside the neuron. So instead of enhancing connections between neurons, it interferes with connections between neurons. And remember, the connections between the neurons is what enables you to accumulate and learn new information. So, with beta amyloid on the outside that's too sticky, this connection ends. And at this point, we should remove this too, right? As this grows in size, it becomes a plaque. Plaque, that's the same word we use to describe what builds up in your heart arteries. And in later videos, you'll discover that these two things have much more in common than just the name plaque. So the end result is something called a beta amyloid plaque. See, it took all that for me to get to the first pathological brain robbers, which are beta amyloid plaques. But we'll just call them plaques for short. Okay, so far we've discussed the first kind of pathological brain robbers, plaques. And they collect on the outside of the neuron. Now we'll discuss the second kind of pathological brain robbers. Earlier, I told you that there are all sorts of proteins in your body. So it just so happens that the other pathological brain robber is a protein 2. This protein is called tau protein. There are actually 6 different tau proteins, and unlike beta amyloid protein that forms plaques on the outside of your neurons, tau proteins exist inside your neurons. Under normal circumstances, tau proteins function to maintain the stability of your neurons. You learned that axons are the long tail or leg of a neuron that sends information to the next neuron, right? I like to think of tau protein as a fiber. In some of my videos on nutrition, I've likened the fiber of a plant to the skeleton of an animal. They both serve the function of providing support and stability. Well, tau protein does the same for your neurons, especially the long axon. So let's use this hair to represent the tau protein. But of course, we're talking about a fiber that lives in a neuron. So it's tiny, it's a microfiber, it's tiny, tiny, tiny. All right? Normally, this hair, this fiber, is strewn throughout the neuron like this. I think it looks a lot like veins. And normally, it's orderly, like combed hair. So tau protein is beneficial under normal circumstances because it supports the neuron. But just as with beta amyloid protein, sometimes tau protein can become detrimental. Most commonly, this happens when the tau protein becomes phosphorylated. Phosphorylation is just a fancy word that means it gets loaded with phosphorus. And when that happens, the hair gets all tangled up like this. So now, instead of having microfibers that support and stabilize the neuron, you have a tangle of microfibers. Instead of having this combed, orderly hair in the neuron, you have a neuron with a bunch of tangled hair like that. Now, when the fibers get all tangled like this, they can no longer support the neuron. Instead, they cause the whole neuron to just collapse like that. The whole thing just bunches up and collapses. It would be like having all your bones get tangled up. You would no longer be able to stand, and your body would have no support system. In the case of a plant, the tangled plant fibers would cause the entire plant to collapse. It would not be able to stand upright either. So these fibers are really, really important. So tau proteins are just tangled fibers. But you know, we doctors have a way of complicating things by labeling them with difficult names. So instead of just using the word fiber, we doctors use the word fibrillary. It really means the same thing. And since these fibers are in your neurons, we add the word neuron to the word fibrillary to create the word neurofibrillary. Neurofibrillary just means nerve fibers. And since these nerve fibers get all tangled up when the tau protein gets phosphorylated, the word for the resulting pathological brain robber is neurofibrillary tangles. What a mouthful. So your second pathological brain robbers that cause Alzheimer's are neurofibrillary tangles that constitute tau protein. but we're going to just call them tangles. So, ultimately, the two pathological brain robbers that cause Alzheimer's are plaques on the outside of the neuron and tangles on the inside of the neuron. Plaques and tangles. This is what Alzheimer's is all about. Now, I know my props aren't sufficient for depicting the real thing, but I hope they make it a little easier for you to understand what's happening in the development of Alzheimer's. Here are some photos that are more sophisticated than my props. Here you see neurons of a normal brain on the left and neurons of an Alzheimer's brain on the right. In the Alzheimer's brain, you can see brownish red clusters of plaques on the outside of the neurons and red tangles inside the neurons. My prop tangles were green, but there was no significance to their color. I just used a goofy wig that I had on hand. Here you see the progression from a normal neuron to a neuron with tangles inside it, to a neuron with more severe tangles inside, and early plaque formation on the outside, to a destroyed neuron with plaques outside it. So what's the overall effect of these plaques and tangles? How in the world do they cause Alzheimer's? Well, it doesn't just stop with plaques and tangles. On the outside of the neuron, the plaques interfere with communication between neurons, and on the inside of the neuron, tangles interfere with the function of the individual neuron. These two pathological brain robbers progress over time, inhibiting more and more communication between more and more neurons and killing more and more neurons. The overall effect is that you lose your ability to remember old things and to learn new things. And both of those cause your brain to quite literally shrink. So your brain goes from this to this. True brain shrinkage. Here are some photos depicting that brain shrinkage. Here you see a cross-section of two brains on the left. The first one is normal, and the second one has Alzheimer's. And on the right, you see the corresponding photo of the neurons in each brain. Here it is again. And again. So Alzheimer's shrinks your brain. In video number 238, I taught you how your brain builds up or breaks down, and you learned that brain buildup contributes to the size and density of your brain. Well, now you see that brain breakdown is just the very opposite. This is very important because when we get to the videos on your options for preventing Alzheimer's, you will see that you can do a whole lot to prevent brain breakdown. So Alzheimer's involves plaques and tangles microscopically and brain shrinkage grossly. But that's not all. Take a look at that last photo again. Notice the ruts on the outer surface of the brain. Here it is in another graphic. What you see is more space between the ruts in the Alzheimer's brains. It's as if the tight, bunched up ruts have become loose ruts with more space between them. Here's a photo of an actual normal brain next to an actual Alzheimer's brain. The normal brain on the left has a lot of ruts, but they are all bunched up next to one another. There's no space between them. But the Alzheimer's brain has wide spaces between the ruts. The more space there is between ruts, the less brain tissue there is. This goes hand in hand with a smaller brain. So here's a photo showing the progression of rut separation. Now some would call these ruts wrinkles, but I prefer the word ruts. I have been known to say that the one place on your body you actually want a lot of wrinkles is your vagina. But now you see that the same is true for your brain. I guess that sums it up for today. Here's what you have learned. Alzheimer's is a result of two pathological brain robbers. There are amyloid plaques on the outside of your neurons and neurofibrillary tangles on the inside of your neurons. Over time, these two pathological brain robbers shrink your brain and rob you of your ability to remember old things and learn new things. Grossly, they result in brain shrinkage and separation of your brain ruts. And next week, you'll be ready to learn about the symptoms and diagnosis of Alzheimer's. Please go to menopausetailor.me to schedule consultations about anything you want. Subscribe to my channel and follow me on Facebook, Twitter, and Instagram. Bye!